Okay, so what you get for your derivative?
How do you find the derivative of x over 20?
How about let's rewrite it. Let's pull that 20 out as 1 over 20, and that way you can just see it as a coefficient in front of the x. So what's the derivative of 1/20th x?
120
And then what does x become?
dx.
Yeah. Okay. What's our next step?
Get d theta dt by itself.
Yeah, eventually, yeah. But maybe we can start looking for some values, right? Anything in the, what do those values?
4 feet per second for dx dt.
Okay. But what do you notice about dx dt here?
Negative.
Yeah, getting smaller, right? When the man is 15 feet from the point, what's that?
X.
Yeah. And we're looking for d theta dt. And if you look, dx dt, we're good to go. D theta dt is the unknown. But what's sticking out is the fact that we want to find a replacement for secant squared theta. So what can we do with that? How can I find a replacement for secant theta? There we go. We're on number 7. Why don't we create a second triangle, right? And let's see, can we fill in all the sides with a numeric value?
Yeah, you can do 15 feet for x, 20 feet for y, and then
How do I find this?
Pythagoras.
Yeah, Pythagoras theorem. A squared plus b squared equals c squared. Yeah. Okay, what you get?
25.
Good. So how can this help us find secant?
Hypotenuse over radiation.
Yeah.
So 25 and 20.
Mm-hmm. Okay, so now we can start filling information in, right? And the rest you just go in your calculator here. Good? Okay. All right, Thomas, I'm gonna have you see if you can walk me through the steps here. So we have a rowboat, pull towards the dock. So here's our starting point. So the boat is always going to be 6 feet below the dock. The rope is here. The rope is pulling the boat closer towards the dock. And we're trying to find d theta dt.
You put x in the bottom, or you just put 2 feet per second. 10.
So right, so 2 feet per second. What is 2 feet per second referring to?
The rate.
Of what?
How fast it's going.
Mm-hmm. So what variable are we going to make 2 feet? Okay, so here's the rope, right? So the rope is getting pulled in, so it's going to be dz dt. Is it positive or negative? Yeah. Okay. At what rate is the angle theta changing? What are we looking for?
We gotta get tan first.
Let's see. It says how fast is angle theta changing? That tells us we're looking for d theta dt. Okay, when 10 feet of rope is out. So which variable is going to hold 10 feet?
X.
We don't have x in this problem though.
No, wait.
Z. So now we have to make a decision. Which trig function are we going to use that will hit theta, 6, and z?
Maybe cosine.
Yeah. Cosine theta equals
6 over 10.
6 over. But the thing is, we don't want to put in the 10, because if we're putting in the 10, that means we're saying that the rope is going to stay 10 feet the entire time, which is not the case, right? So that 10 is going to help us later on, but not in the beginning. Okay. We want to find the derivative, but to find the derivative, we can get that right side to be a little cleaner, right? So that we can quotient.
Maybe like 1 over 6 times z.
But 6 is in the numerator, right? So this will be the case if it was z over 6. If it was z over 6,
Or like the opposite.
we can make it 1/6 z.
Yeah.
But what can we do so that we can move the z so that we don't have to look at a denominator? Where can I put that z?
I don't know.
What if I move it up top?
Oh, should you like z negative to negative 1?
Mm-hmm. Okay, so now we found the derivative. Okay, cosine's derivative is negative sine. So what will the derivative end up looking like?
What would you put as u?
I'm sorry?
What's u?
Okay, the u is theta. The u represents the theta. So what's cosine's derivative?
d over dx times, or no, negative sine.
Yeah.
Times theta times.
Right. What's the u prime in this problem here?
Would it be like? I don't know. What would it be?
Okay, so we're doing with related rates. So time is going to be impacting every variable. So it's going to be what? D theta dt. Okay, what about the right side?
The right side would be d over dx times cosine, or not times.
I think the right side we can just do power rule. Right, so what's the power rule for 6z to the negative 1?
What?
What's the derivative of 6z to the negative 1 if we just want to use power rule?
Would it be negative 6z times z to the power negative 2?
Okay. And also, z is being impacted by time, so we also need to include what?
d theta over dt.
Well, theta was over here, right? But now we're dealing with z, so it's dz dt.
dz.
Okay, so we can do a little bit of cleanup on the right side. I'm going to push that z back down to the denominator. And now we have to find a replacement for sine theta. So we're going to have to create a second triangle because we want this sine theta to completely go away and we want a number to replace sine theta. So here's our second triangle. We want to fill in all the sides with numbers. So the 6 we can carry over. What can we replace the hypotenuse with?
Z squared.
Okay, now we can bring in that 10, right? And how can I find?
What's the point of the second triangle?
So that we can, because we want to fit, right now sine theta is getting in the way of helping us solve for d theta dt, right? Because we have z, we have dz dt, sine theta, we want a ratio to replace that because we want d theta dt to be the only variable left in the problem.
Would the bottom one be 8?
Yeah. So now we can cleanly decide what sine of theta is, right? What's sine of theta going to be equal to?
Okay, 8 over 10.
Yeah, which reduces to be 4/5. So now we should be in the clear, right? Because everything that has a variable is now being replaced now with a number, and then we can now solve for d theta dt. -3 over 20 radians per second. Good? Okay, which part?
Wait, I need to see this for a second. Oh, that's why I did wrong. I did z squared instead of z to the -2.
Oh, yeah, yeah. It needs to be in the denominator.
Oh, when's the next quiz for test?
Tuesday.
Okay.
Recovery for chapter 5 is on Wednesday.
Okay, yeah.
And I'll hand back the test to you tomorrow. Okay, good. Ethan, all right, so Ethan, have you tried number 9?
We did that in class, right?
Oh, did we? I don't think we got to number 9, did we?
I think we did.
It's okay, we can do it again.
Okay.
So we have a kite move horizontally at a speed of 8 feet per second. Which variable can hold that?
X.
Yeah. But it's a speed, right? So we want that to be dx dt. Okay, at what rate is the angle between the string and the horizontal decreasing when 200 feet of string has been let out? Where's the 200?
That's Z.
Let's see. Okay, so, but do we want to involve Z as part of our trig function?
No, not
Okay,
yet.
not yet. Because we have dx dt, we would prefer to use x instead. Okay, so which trig function can we use?
Tangent.
Yeah. Okay, how would you set that up?
Tangent theta equals 100 over x, or 100 times x to the negative 1.
Good. Okay. Find the derivative. Secant squared, right? Okay, right side becomes
Negative 100 x to negative 2 dx.
all right. Clean that up. We can bring that x down to the bottom. Okay, second triangle.
Second triangle, Z is 200, Y is 100. And then X is 173.
Yeah, I'm gonna leave it as exact value, 100 root 3. Okay, so now we can figure out what secant theta is, right?
Is that adjacent hypotenuse?
Mm-hmm.
So it's 100 root 3. Wait. No, 200 over 100 root 3.
Which reduces.
To 100 to.
Yeah, so now it gets easier, right? Now you're just plugging in and keeping track of your numbers.
do you do 100√3 squared?
Yeah, so in the calculator, you would need to put another set of parentheses. So parentheses 100√3. Otherwise, the calculator may only just square it. We want the whole thing squared, so 30,000.
Oh, okay. And then 100 divided by that.
Mm-hmm. So 3 times negative times 8 over 4 times 30,000.
Oh, okay.
I can just put it all in one fraction if I want.
Oh, okay, that makes sense.
Yeah. Do you know how to get to that fraction button?
No, I just.
Okay. If you hit alpha y, you see that n over d.
Y.
Alpha y equals.
Oh, that.
See that n over d? Should have it. Oh yeah, let's go back to the next one. Oh, sorry. Yeah, some of the newer feature has that option.
Oh.
But you just have to use parentheses then.
Oh, okay.
Okay, last one here. Thomas. We have it's always going to be a right triangle. Rocket is launched 30 feet from Maria, rising vertically at a constant rate of 20 feet per second. How fast is the angle of elevation from Maria to the rocket changing at that moment?
wait. When it says 30 feet, is that like 30 feet horizontally or just 30 feet?
Horizontally.
Okay.
Yeah. So that's not changing, right? But the rocket distance is changing. So let's do this. All right. So Thomas, how will we start this process here?
You got to put horizontally 30. Do you not put 40 for one?
Yes, 40 is equal to y, but that's going to be information that's later, right? If we put 40 here, that means it's always staying 40, and that's not true.
Then you do tangent 4 over 3.
Y over 30, right?
Yeah, or y over 30.
All right. This 40 is going to come into play much later. Hey, what's next?
Inverse it. Like you make it equal to secant. Like you did the
Derivative. Yeah. Secant squared, right? How about the right side?
The right side is secant squared times theta of that.
Yeah.
Or the other side.
This side.
Which you do tan theta and you do d over dx.
So we found the derivative from tangent to secant squared, right? So the left side is taken care of, but now we need to find the derivative of y over 30.
Oh, wait, would you do y over 30? Or no, what do you do?
What if we think of y over 30 as 1 over 30th times y? Does that make it easier? What's the derivative of 1/30th times y? Mm-hmm. And what happens to the y? Kind of. But what's the underlying variable that's impacting everything here? Time. So how does time play a role for y? It becomes dy dt. So with related rates, every variable is going to turn into some sort of a d over dt. Okay, so I think, let's see. What other information do we have from this problem? What about this? The rocket is rising vertically at a constant rate of 20 feet per second. What variable could that be?
I don't know.
Vertical is dealing with y, right? But movement is going to be dy dt. Right? So 20 is going to be dy dt.
So that's what that is?
Yeah. But just like before, we still have this sticking out with nothing to replace yet, right? So we need to create a second triangle with information enough to help us replace secant theta with the fraction, with the ratio.
What's secant?
Secant is the reciprocal of cosine.
So like 1/%?
Mm-hmm. So what can we fill this triangle with? Can you help me figure out all the side lengths?
Yeah, 40 on the vertical, 30 on the horizontal, and then 50 in the
What's secant theta?
40 over 50.
Mm.
Or no, 1 over, wait, 1 over.
Okay, let's figure out what's cosine. What's cosine?
40 over 50.
Mm.
Opposite of 30.
That's sine, right? Cosine is adjacent.
Oh, adjacent over. So 30 over 40.
30
50,
over
50.
50.
30.
So that's cosine, right? So therefore, secant is,
1 over.
which is,
Like
yeah, 50 over 30. Yeah, pi over 3. Okay, so now we should be in the clear, right? Everything that we need is in front of us now. So we can plug in and solve for d theta dt.
What?
We can solve for d theta dt now.
Yeah.
Just plug everything in, right? Yeah. Okay, I'll flip that 5/3 over to the right side. Theta is always going to be radians. Time is, in this case, seconds, so 6/25.
Did you not need to like divide it on the other side?
I did. Dividing by a fraction is the same thing as multiplied by the reciprocal,
Oh,
right? So I just flipped it.
Okay.
Yeah.
Okay, yeah, that makes sense.
Good. All right. You guys should at least feel a bit more comfortable now with related rates. Okay, so tomorrow we'll do inverse trig. All right. Tam, any questions?
No, I think I understand.
Good, good, good. All right. See you guys tomorrow.
Thank you.
All Aye.